everyone, this is Kalpana here. So in this video we are going to see a problem from differential equation. So we are going to solve a differential equation using variables as separable method. So let's get going. Problem: solve dy by dx equals to 1 plus y square by 1 plus x square into xy using variables as separable method. Given differential equation is dy by dx equals to 1 plus y square by 1 plus x square into xy. Consider it as equation 1. Okay. We can write this as dy equals to 1 plus y square by 1 plus x square into x into y into dx. Now take all the x terms in LHS. Okay. So you're having 1 plus y square by y in RHS. So you're taking it to left hand side. You'll get y by 1 plus y square into dy equals to 1 by x into 1 plus x square into dx. So now integrating, your variables are separable, right? Your variables are separable. Integrating integral y by 1 plus y square into dy equals to integral 1 by x into 1 plus x square into dx. Now consider integrand of RHS 1 by x into 1 plus x square. You could write this as a by x plus bx plus c by 1 plus x square. Then 1 by x into 1 plus x square is equals to, you get denominator x into 1 plus x square, and the numerator you'll get a into 1 plus x square plus bx plus c into x. Here you can cancel x, 1 plus x square, 1 plus x square. You'll get 1 equals to a into 1 plus x square plus bx square plus cx. Now by comparing the quotient of x square, you'll get, comparing the coefficient of x square, you'll get 0 equals to a plus b. Okay. And now comparing the quotient of x, you'll get 0 equals to c. Now if you compare constant, you'll get 1 equals to a into 1 a. That is a equals to 1. Therefore a equals to 1. Now substitute a in this. You'll get 0 equals to 1 plus b. Then b equals to minus 1. Now we are having the value of a, b and c. You can substitute all these values here in the place of a, b and c. Then we'll get 1 by x into 1 plus x square equals to a 1 by x plus b is minus 1 into x plus c 0 by 1 plus x square. From this we'll get 1 by x into 1 plus x square equals to 1 by x minus x by 1 plus x square. So here you can replace this integrand by 1 by x minus x by 1 plus x square. Since 1 by x into 1 plus x square is equals to 1 by x minus x by 1 plus x square. So you could write this as integral y by 1 plus y square into dy equals to integral of 1 by x minus x by 1 plus x square into dx. Again, you could write this as integral y by 1 plus y square into dy equals to integral 1 by x into dx minus integral x by 1 plus x square into dx. Now we are going to use some formulae. Integral 1 by x dx equals to log mod x plus c, and integral f dash of x by f of x into dx is equals to log mod f of x plus c. Okay. So this becomes, here you are having y by 1 plus y square. Let's consider f of y equals to 1 plus y square. Let's take f of y equals to 1 plus y square. Then y dash of y will be, then f dash of y will be equals to derivative of 1 with respect to y is 0 plus derivative of y square is 2y, right? Then f dash of y equals to 2y. Now to take integral 2y by 1 plus y square, which is integral f dash of y by f of y into dy is equals to, by applying this formula, you'll get log mod 1 plus y square, right? So in order to use this formula, we need a 2 here. For that purpose, what we are going to do is, we'll multiply and divide 2 to this integral. Okay. Now, you can multiply and divide 2 to this integral. You'll get 2 by 2 into y by 1 plus y square into dy equals to integral 1 by x into dx minus integral, here also you can multiply and divide 2. Okay, if f of x equals to 1 plus x square, then f dash of x equals to derivative of 1 with respect to x is 0 and derivative of x square is 2x, right? So in order to apply this formula, we need 2x by 1 plus x square into dx. For that purpose, we are going to multiply and divide 2, right? Fine. So you could write this as 1 by 2 into, now take this 2 inside the integral, you'll get 1 by 2 into 2y by 1 plus y square into dy equals to integral 1 by x into dx minus 1 by 2 into integral 2x by 1 plus x square into dx, right? So this is of the form f dash of y by f of y, okay, dash of y by f of y, which is equals to log mod 1 by 2 into log mod 1 plus y square equals to integral 1 by x dx is log mod x minus 1 by 2 into integral f dash of x by f of x is log mod 1 plus x square. Since everything is in log, so we'll write integral constant in terms of log. We'll get log c as your integral constant. So you could write this as 1 by 2 log 1 plus y square equals to log x minus 1 by 2 log 1 plus x square plus log c. Now take this minus 2 into log 1 plus x square to LHS. You'll get 1 by 2 log 1 plus y square plus 1 by 2 log 1 plus x square equals to log x plus log c. You'll get 1 by 2 into log 1 plus y square into, not into, plus log 1 plus x square equals to log x plus log c. Since log a plus log b equals to log ab, then you could write this as 1 by 2 into log 1 plus x square into 1 plus y square equals to log cx or xc. Okay? And again you could write this as log 1 plus x square into 1 plus y square equals to 2 log cx then log 1 plus x square into 1 plus y square is equals to, we know that m log n equals to log n power m. Then you could write this as log cx whole square. Okay. Since if log a equals to log b, then a equals to b. Then this becomes 1 plus x square into 1 plus y square equals to cx whole square. Then 1 plus x square into 1 plus y square equals to cx whole square can be written as c square into x square. Since c is constant, c square will be also a constant. Again, you could write this as 1 plus x square into 1 plus y square equals to c into x square. Therefore, this completes the problem. Therefore, 1 plus x square into 1 plus y square equals to cx square is the required solution. This is all for now. Hope you will understand. We'll see you in the next video. Until then, bye bye.